right, in section 6.3, we are adding and subtracting radicals. And remember, subtraction is just adding a negative, so it's not like it's a different subject. I wanted to look at number 5 first, just because we can't always add or subtract things. They have to be alike. If you think about when we learned about like terms, in like terms, we mostly talked about variables, but here, these radicals, sometimes we can put them together and sometimes we can't. For instance, in this one, we can't put them together because the radicals are not the same. I have 5 of square root of 2, but I don't have any other square roots of 2 to combine with it. This is a 2 square root of 5. They are not the same thing. I cannot combine these. You have to have exactly the same thing under the radical in order to combine these. So it's not possible to combine these, and this is as simple as this would get. On the other hand, sometimes you can combine things and it doesn't look like you can at first because they're not all the way simplified. On number 5, we had prime numbers under those radicals, or we had radicals that couldn't be simplified any further. And that's not the case in some of these. Okay, so let's look at each one of them. The square root of 6. Well, 6 is 2 times 3. There's no way to get a square out of that, so that's as simple as that one's going to go. Well, what's the square root of 36? Well, it's 6. So far, I don't have anything I can combine. But what about the square root of 216? Well, let me see. Let me go over here and let me factor it. I know that 2 goes into 216. That'll go 108 times, okay? And the reason I just chose 2 was it was even. 2 goes into 108 54 times. Oh, I start seeing something I'm a little more familiar with. 54 is 9 times 6, isn't it? Well, 9 is 3 times 3, so there's some prime numbers. And 6 is 2 times 3. So there's my prime numbers. Let me list them all. We've got 1, 2, 3 2s and 3 2s and 3 3s. Okay, so what can come out here? We just recopy the ones that we've already simplified. Alright, so I can get a copy of a 2 out and a copy of a 3 out. So I'll have a 2 times a 3. I brought each one of those out front. And what's left on the inside is this 2 and this 3. That didn't go away. Okay? Now on the outside there, 2 times 3 is 6, and on the inside, 2 times 3 is 6. Now, there are some things I can combine, because I have 1 square root of 6 up here. It didn't have a 1 in front of it, but I could write it there. A square root of 6 and a 1 square root of 6 are the same thing. Well, if I have 1 square root of 6 and somebody gives me 6 square root of 6s, that makes 7 square root of 6s altogether. Now I have this whole number 6. I can't put that together. If it had been 6 square roots of 6, I could have combined those, but I can't put those together. So what I'll probably just do, usually what they do is they write the whole number part first, so they'll probably put 6 plus 7 square roots of 6. They'll just use the commutative property to switch the order of those there, and that would be my answer for 7. All right, for number 15, we're adding 2 radicals together, but underneath a radical, there's a fraction. Now, these are, when I'm adding these radicals, unless they're exactly alike, I can't combine them. But there might be something I could do here. And so what I'm going to have to do is let's look at each one of these. Let's go ahead and break them apart into square root of 2 over square root of 3 plus square root of 3 over square root of 2. We're just going to break each radical up and give each numerator and each denominator its own radical. Now let me work on simplifying this. You know, I know that I can't have this square root of 3 in the radical, so maybe what I want to do is go ahead and get another square root of 3 to get rid of it in the radical, because we know we shouldn't have it in the radical. So for the first term, I'm just messing with the first term. I'm going to multiply by square root of 3 over 3. That's going to be square root of 2 times 3, which is square root of 6 on top, and then square root of 3 times square root of 3 on the bottom is 3. Now let me go do this second part here. I'll do it in blue just so you can see the 2 parts. I want to get rid of the square root of 2 on the bottom, so let me multiply by square root of 2 over square root of 2, because I've got now 2 copies of square root of 2, which would give me a 2 on the bottom there, and I'd have square root of 6 on top. Now, I'm down to fractions now, but they don't have a common denominator. So I can get a common denominator now. So that's what I want to do next, get a common denominator. First I simplified, and then after I got them all the way simple and I'm all proper and everything, I'm going to get a common denominator. Alright, Now, if you look, I've got a denominator of 3 and I've got a denominator of 2. So a common denominator would be 6. Let me multiply this one over here by 2, and I'll need to multiply the top by 2. And to get a 6 on the other one, I'll need the denominator to be multiplied by 3. So I'll also have to multiply the numerator by 3. All right, so here's what I get. I get 2 square roots of 6 over 6 plus 3 square roots of 6 over 6. Oh, now I've got my common denominator of 6, and I can put these together. That would be 2 square roots of 6 plus 3 square roots of 6. Can I combine those two? Yes, I can, because it's like I have 2 of those things plus 3 more of those things, and those things just happen to be square roots of 6's. So what we do is we write the square root of 6 down, and we add how many up that we have. We have 2 of them and then 3 more of them, so we're adding those numbers out front. We get 5 square roots of 6 over 6, and that's how you'd want to write 15. It's all the way simplified. All right, on 19, we see that we have something that looks like we're going to need to use the distributive property because we have a parentheses and we have a number out front, and that's exactly what we're going to need to do. Now, when we multiply these things, when I say square root of 2 times square root of 8, I can write that they're both square roots, so I can multiply inside of the radical. And then there's a plus sign. I'm going to say square root of 2 times square root of 10. And since they're radicals, we can put them under the same radical. So what do we have here? We have the square root of 16 plus the square root of 2 times 10 is 20. So we need to simplify each one of those radicals. Well, the square root of 16 is 4, okay? And again, the only reason I'm not putting plus or minus 4 is that they already had the radicals there. I didn't solve and square root something, so I don't need to put plus or minus, okay? And then the square root of 20. Well, if you think about 20, it is 4 times 5. I'm going to write it that way because 4 is the biggest square in 20. I could have come over here and I could have prime factored it, and I could have seen that I could have taken a 2 out, or I could do it the way I did it over here and look for the biggest perfect square of 4. Well, the square root of 4, remember I can now look at it this way. That's the square root of 4 times the square root of 5. If I want to write that step in, I can. The square root of 4 is 2, and then I've got the square root of 5. So my answer would be 4 plus 2 square roots of 5. And again, you could have come over here and found 2 times 2 times 5 and pulled your 2 out front that way if you'd wanted to. There's several ways to do radicals. Prime factoring is one of them, and the other way is looking for the biggest perfect square in the number. All right, 25, we have a fraction, and we know that if we look at it, the one thing that we got to do is get rid of that radical in the denominator. Now, there may be other things I need to do, but I'm just going to start there because we got to start somewhere, right? First of all, when you have a plus or minus, it joins 2 terms together, and they are one entity. So I'm going to put parentheses around that just to show that. Now, I want to get rid of the square root of 2 in the denominator, so let me multiply by square root of 2. The reason I need to do that, remember, is I need 2 copies of the same thing to get rid of the radical and to get the square root of 4, which is just 2, or I can say I've got 2 copies of square root of 2, which is 2. But if I do it to the bottom, I got to do it to the top. So here's what I really have. I'm going to write it like this because I think most people would rather see it this way. We're going to have to use the distributive property, just like we did in the last problem on this video. Okay, so here we go. I got my denominator cleaned up, but now I got to clean up my numerator. I've got the square root of 2 times 6. I'll put my 2 on the bottom. Remember, when I distribute, since they're both square roots, I can write them under one radical. And then I've got a minus the square root of 2 times 24. So I'll just put 2 times 24 underneath the radical there. All right, that ends up being... Now, I can do a couple of things here. Here's what I'm going to do. I'm just going to prime factor all the numbers under there. 6 is 2 times 3. So I can see, this will make it easier for me to see that, I can take a 2 out front from that first term, and I'll have a 3 left over. So I'll just do that. Now let me work on this term right here. That's 2 times 24. Well, if you prime factor 24, you could say 4 times 6 if you wanted to. 2, 2, 2, 3. So it's 2, I had a 2, and then I have 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. Okay, there's a 1 2 that can come out. There's 2 2's that can come out. So I'm going to have 2 times 2 out front, and I'll have a square root of 3 left on the inside. Another way I could have looked at that is said, well, 2 times 2 is 4, times 2 is 8, times 2 is 16, and the square root of 16 is 4. So when I rewrite it, it's going to be 4 square roots of 3 there. Now, if you look, I can keep going on simplifying this. And that's what's so hard about simplifying is you got to know when to stop. I have like terms here on the top, don't I? In the numerator, I have square roots of 3. I have 2 of them, and somebody wants to take away 4 of them. That would leave me minus 2 square roots of 3 over 2. But once I do that, I see something else that happens. I see that 2 goes into 2 one time, and 2 goes into 2 one time. Because remember, outside of the radical, if I have numbers outside of the radical, I can reduce those. It's just I can't do something outside of a radical and inside of a radical. That doesn't work. But if they're both inside or both outside, you can reduce them. So that's just negative 1 square root of 3, and how we would write that would just be negative square root of 3 there. And that's it on that one. All right, in order to take care of a problem like this on number 35, you would just, again, you're going to simplify each thing separately and then see what you have that you can put together. Now, 8, I know that 8 is 2 times 4, right? Well, 4 is the biggest square in 8. So on that first term, let me just do it first. I know the square root of 4 is 2. I could bring that out. Now, x cubed, I could write that as x if I wanted to. And I can see there's a pair of x's here, so I can bring an x out, or the square root of x squared would just be x on the outside. And what would I have left on the inside once I moved those? Just 2x. That's as simple as that term can go. Now let me do the second term. I'll do it in kind of a bluish color so we can kind of keep them separate. If I look at 18, I know that 18 has a perfect square in it. Remember that you could always list your perfect squares and kind of go, well, what's the biggest perfect square that divides into that? Well, 9 times 2 is 18, right? And 9's a perfect square. That's why I picked it. So, I mean, again, I could say, well, what's the square root of 9? It is 3. And I could bring it outside and put it with the x, and I would have a 2x left inside. Let me just copy that down here. Once I get that all the way simplified, if you look, both of these are square roots of 2x's. I have 2x square root of 2x, and somebody takes away 3x of my square root of 2x. This is kind of weird because it's almost like a like term and a like term if you think about it. I know that I can take these things out front, and if they're alike, I can subtract them, and they are 2x minus 3x. Let me go ahead and write in what I'm doing here and put an extra step in. I'm subtracting 2x minus 3x in front of my square root of 2x. Well, 2x minus 3x is just going to be negative x square root of 2x. So that's how you do 35. You have to simplify each one and then notice that they're like terms.